Okay, this is Mr. Long, and I'm back with, I believe, part 3. We're on question 4. In a spacecraft, the carbon dioxide exhaled by astronauts can be removed by its reaction with lithium hydroxide, LiOH, according to the following chemical equation. So we got CO2 reacts with 2LiOH to produce lithium carbonate plus water. So we want, if 20 moles, 20.0 moles of CO2 is exhaled, which is the average amount exhaled by a person each day, how much in grams Li2CO3 of that is produced? So we've got moles A, we're going to go to moles B, then mass B. So we're going to start with 20.0 moles of CO2, moles A, and so in moles of CO2, we're going to compare that to moles of Li2CO3. Moles of Li2CO3. And let's look at the equation here. There's no number by lithium carbonate, so it's a 1. And by CO2, that's also a 1. So it's a 1-to-1 ratio. That's easy. And now we've got to go to grams of lithium carbonate. So in 1 mole of LiCO3, we get so many grams of LiCO3. So, yep, we've got to add this up again. Lithium is equal to, let's look on the periodic table, that's going to be 6.9. And we got 1. No, we don't have 1. Whoops, using Y. We got a 2 here. Okay. So, times 2 is equal to, and then we got carbon is equal to 12.0 times 1 is equal to 12.0, and we got oxygen is equal to 16.0 times 3 is equal to 48.0. So this, like 7 times 2 is 14. This would be 13.8. Now we add this up. 0.8. 3 and 2 is 5 plus 8 is 13. Put the 1 up there. So we got 1, 2, 3, and 4. I'm sorry, 1, 2, 3, and 4 makes 7. So that should be our molar mass there for number 4. Now, we're going to put 73.8 up here. Do the math. Now, pull our numbers over. It's equal to 20.0 times 73.8, and that's it. So the rest are 1s. So let's get out this handy dandy cheap calculator here. So we got 20 times 73.8 is 1476. Now we want 3 sig figs because we're limited there, and we got 3, so we want 3. This 6 rounds up, add 1 to that 7 to make 8. 1, 4, 8, 0. That's 3 significant figures. We're in grams of Li2CO3. Let's box this guy up, and that is our answer there. So if you're not sure on any parts of these problems, just stop, pause, rewind, go back, and look at it again. Okay, now we're going to be on number 5. And we start by having to balance this equation for number 5. So we got sodium, which reacts explosively with water, produces a strong base, NaOH, plus hydrogen gas. So let's do this. 1, 2, and 1, 1, and 1, and 3. Well, the first thing we got to do is increase our hydrogens on the reactant side, so we have to put a 2 here. 2 times 2 is now going to be 4. 2 times 1 oxygen is now 2. Okay, we got to increase our oxygen on the product side, so you have to put a 2 here. 2 times 1 sodium is now 2. 2 times 1 oxygen is 2. 2 times 1 hydrogen is 2, plus 2 makes 4 hydrogens. We're making progress. Okay, got to even up the sodium, put a 2 there. We got that, and there we go. We got a 2, and a 2, and a 2, and a 1. So on a multiple choice test, you're looking for a 2, 2, 2, 1. Okay, and this would be a single replacement reaction because you have a single element coming in, reacting with a compound, and it is more reactive. Sodium is more reactive than hydrogen. Hydrogen gets the boot, and sodium gets the cheese, so to say. Well, let's go look at 5A now. We balanced that. This was A. So on 5B, how many moles of sodium are required to produce 5 moles of NaOH, sodium hydroxide? Well, that's not going to be that hard. It's a moles A, moles B problem, so it's short. So we start with what we're given. So on B, we got 5.0 moles of NaOH, and so we have this, and we're going to have moles of NaOH on the bottom. How many moles of sodium are there? In front of sodium is a 2, in front of NaOH is a 2. I like when they do that. That cancels out, those units cancel out, equals 5.0, and we're in moles of sodium. Okay, so there we go for that one. Now let's look at C. How many moles of hydrogen are produced in the reaction with 5 grams of water? Let's get this up here. Okay, so what kind of problem is this? Well, you're starting with grams of water, so it's mass A. And you're going to go to moles of hydrogen, that's moles B. So you're going to go mass A to moles A to moles B, 2 steps, and you're done. So for C, we got 5.0 grams of water, and by the way, that's 2 sig figs. We're going to go to moles A, moles of H2O. So we know there are 18 grams of water in 1 mole of water. And if you weren't sure, you would just write this out again. Okay, and here we're going to have, oops, I made another mistake. Boy, what did I do that for? Okay, bad Mr. Long. Let's try this again. 5.0 grams of H2O. So we're going to have 18.0 grams of water on the bottom because you got to have a gram there equal to 1 mole of water. So everybody makes mistakes, and I make lots of them. Okay, so we're going to compare moles of water, and we are going to moles of H2. Okay, so by water, here we have the number of 2 right there, and by H2 we have the number of 1. So we've got a 2 here and a 1 there. So here, we've gone from mass A to moles A to moles B. Cancel your units. Okay, so it's equal to 5.0 divided by 18.0 times 2, so we'll say 36.0. So let's see what this calculator says. 5 divided by 36 is equal to 0.138. Let's round that guy up. 0.14 moles of H2. And there we go. There we go, and that's our answer. So let me just roll this down here a bit. So yes, everybody makes mistakes, including me. I make lots of them. So anyway, that is the answer here for this final problem on the mixed stoichiometry problem set for 5C. And there you go. So pause, rewind, and be careful for little mistakes. Okay.